Hello students, welcome back. So in this session, we are going to be covering covariance matrix and correlation matrix. This is a subject of descriptive statistics. So first thing you want to do is import your NumPy. I am importing my NumPy. I'm creating an alias as NP. So let's say you have two sets of data, X and Y. Your X represents the game hours, how many hours somebody plays video game. And your Y represents what was their score in the exam the next day. So let's compute the covariance matrix. This one allows you to find relation between two variables, in this case, X and Y. So I'm printing my covariance matrix, and then at the same time, also printing the relation between two variables, study hours and and exam scores. So first I print my covariance matrix. So this is my covariance matrix right here. And since I want to print the relation between two variables, so that will be your covariance matrix row index 0, column index 1. That would be this right here. So it prints out this number, which is this right here. Then also you can determine correlation coefficient. So in this case, there's an inbuilt method called coef that will print out your correlation coefficient between the two variables. The difference between covariance matrix and correlation coefficient is that covariance matrix is not scaled. This one actually depends on the number. So depending on your number, this could actually range anywhere between, it can go any range because of the numbers that are present over there. This one right here is always going to be between -1 to +1. So for the most part, we deal with correlation coefficient. And this way, it allows you to compare the values among different variables. Okay, so I'm going to show you how a correlation coefficient is done on this data set real quick. So if you remember from your high school math, the way you did correlation coefficient, this was the formula that was used. Covariance between x and y is given by 1 over n minus 1 summation of your each point minus the mean times each point minus the mean of y. And you multiply these 2 points together. So this is the essential formula. So that's what's happening over here is basically I'm just calculating my covariance between x and y using that formula. Now, according to this formula, this should be equal to 1 over n minus 1. In this case, your n is equal to uh, your uh, your number of points. So in this case, my number of points is 1, 2, 3, 4, 5, 6, 7. So it's going to become 1 over 7 minus 1 is 6. This is, by the way, sample. Okay. This is not a population. Because we're dealing with sample, we do n minus 1 over here. Okay, and then you multiply each one of the. So in this case, calculate your mean. So let's say my mean is x bar for this right here, and the mean for y is, let's say, y bar. I'm not calculating mean right now. I'm not calculating the mean for the x and y. I'm just assuming that this is given to, and you can find this easily. Okay, so once I know my mean, then you can just multiply, do your computation. So in this case, this is going to become 1 minus x bar times, this is going to become 90 minus y bar, okay, plus same thing. Then it's going to become, so we're done with this, we're done with this. Now we're going to go 2 and 90. So 2 minus x bar times 90 minus y bar plus, then we do with this, 3 minus x bar and 85 minus y bar. And I can keep going like this all the way towards the end right here. Okay, and then solve this, and this answer will come out to be your covariance between x and y. And the answer was 30 minus 13.214. That's your answer. Okay, and then same thing, by the way, you can also calculate the covariance. This right here is a covariance between x and x. So the way this covariance matrix works is like this. So the covariance matrix between x and y is equal to, this is a matrix, it's a covariance between x and x. Okay, covariance between x and y. This is covariance between y and x, and this is covariance between y and y. So this is the formula that's used to calculate this covariance matrix. All right, and then when it comes to finding correlation coefficient, that's easy. You just divide each one of the terms by your variance. So in this case, divide by variance of x. divide by variance of x again. In this case, you're going to divide by variance of x, variance of y, because you have x and y. In this case, you're going to divide by variance of y, and then variance of x again. In this case, you're going to divide by variance of y and variance of y. And this thing will give you your correlation matrix, a correlation coefficient. So here I'm using this logic right here. So this is how I find my correlation uh, coefficient between two variables. Okay, now in this case, I just use simple two variable. What if you have more than two variables? Well, let's look at this. This one right here actually has one, two, three, four variables. Well, you can do that too. So create your one giant X right here. Okay, and then input this call your cov method, COV, and input your x1, x2, x3 inside this, and that's going to calculate your covariance matrix among all variables. And likewise, you can calculate the correlation coefficient. So the way you read this is like that. Let's look at this one right here. This one is this whole one. This one represents x1. This is a column x1. This is column x2. This is column x3, and this is column x4. This is row x1, x2, x3, x4. So this one is covariance matrix between x1 and x3. So the answer is 10. Okay, so in this case, the relation between the variables x1 and x3 is 10. So if you come over here, your x1, x3 is this one. This is my x1, and this is my x3. This is how you read this. Okay, and same thing, same way you can read these numbers. So they basically pretty much, the indexes are pretty much same. The only difference is the range of the numbers is changed now. In this case, all numbers are going to be between -1 to +1. And your diagonals is always going to be 1, by the way. So correlation coefficient, that's one of the property. Your diagonal is always going to be 1. All right, thank you.